Alright, so this is a new theorem you haven't learned in year 10, but it's quite easy to learn. But we have to define some new terms. Ratio of intercepts. So this is not the intercept that you learn normally. Say if I draw a line there, this 3 is called the x-intercept. This is different from the idea you learn from number plane. This is intercepts in geometry. Let's look at what that means. Intercepts a point P on an interval AB. So that P is on interval AB. Divides the interval into two intercepts. AP is an intercept. PB is an intercept. Okay, so that's what intercept is when you put a point on a line, it divides into two intervals. These two intervals are called intercepts. Okay, different from the x and y intercept you've seen earlier. Okay. Let's look at how this theorem can be explained. So we're going to look at this theorem. Two transversal cross three parallel lines. There's three parallel lines there. 1, 2, 3. These are the two transversals. And the ratio of the intercepts, on one transversal, so that's the ratio of two intercepts. These are called intercepts. The ratio of two intercepts on one transversal is the same as the ratio of intercepts on the other transversal. So let's look at how we can express this in this diagram. So if I call this length A, this length B, this length C, this length D, then the ratio of A and B is same as the ratio of C and D. Okay? Very easy. Just this length divided by this length equal to this length divided by that length, as long as there are three parallel lines. Okay, write it down. That's called the ratio of intercepts. So the intercepts of one transversal is equal to the intercepts on the other transversal. Alright, any questions? We're going to apply this to different questions, and you'll find it is very easy theorem to use and very easy theorem to apply. Alright. So remember what intercepts is. The key word is intercepts. These are called intercepts. When we cut a line into parts, these are called intercepts. Okay? Oh no. Okay, thank you. Alright, let's move on to do question 27. Find x. So what do? These are called intercepts. 1 and 2, right? So you do x over 3.7 equals to 5.9 over 2.8. Now, why do I do x first? Because x is the polynomial. It's better to put the polynomial on the top, because once you have the polynomial on the top, finding the polynomial is easy, because all you have to do is to multiply both sides by 3.7. Right? Like this. So you end up using your calculator, 5.9 over, you'll get some decimal place which you have to round times by 3.7, which is 7.79. How many decimal places does it say? So you just round to 2 decimal places, so 7.80. Okay, write it down. So ratio of intercepts, x over 3.7 equal to that. Now that looks a bit like similar triangle, except these are ratio of intercepts, not the ratio of sides of the triangle. So be careful. What reason do we give? We have to give a reason. The reason you give is this. You say ratio of intercepts. Ratio of intercepts. I think that's how you shorten it. Ratio of intercepts of parallel lines. Maybe something like this. Ratio of intercepts of parallel lines. So not the ratio of matching sides in similar triangle, it's ratio of intercepts on parallel lines. Does it also have to be 3 parallel lines? No, it can be 2 parallel lines. I'll show you later. Alright, let's look at this example. We can also use this example to find x. Okay, let's look at this one. So we can do x over 3, but x over 3 equals to AC over CQ, right? The ratio of these two intercepts equal to the ratio of these two based on these parallel lines, right? And then you do another thing. There's another pair of parallel lines, which means you have another ratio of intercepts. So you can write AC over CQ equal to 7 over 4, right? So that's based on the other two. H, A, that's A. Does it look like H? That's AC. Okay, good. Now, hang on. AC over CQ. AC over CQ. Oh, yeah, that looked like H. Sorry. I thought it's the other one. Let me write this again. AC. Okay. Now, the good thing is that we can make them equal, right? They're equal. So you can say, therefore, x over 3 equal to 7 over 4, right? So you can apply this theorem twice to work out the missing sides. The reason for each is ratio of intercepts. Maybe just say ratio of intercepts, easier. And this one as well, ratio of intercepts. So give a reason every time you write down a formula. After we finish, we're going to find x. Okay, so we're going to times both sides by 3, and that will give you the answer. So what would that be? X equals 7 over 4 times 3. So you do 7 over 4, 7 divided by 4 times 3 equal 5.25. Yep. Got it. Alright, 5.25. Now notice that in this diagram there's no 3 parallel lines, but it doesn't really matter because when you draw 3 parallel lines, if the 2 transversal meet on the 3rd parallel lines, you don't really need the 3rd one, isn't it? Because when they intersect, it creates the intercepts, right? So therefore, you can just need 2 parallel lines to use the theorem as long as the transversal meet at a point. But if the transversal don't meet, they need 3 parallel lines to create the 2 intercepts. Okay? All right, good. After we do this, we'll do another question. All right, good. Find the value of the pronumerals. Now, as you can see, the 2 transversals meet at a point. You don't need the 3rd parallel lines there, right? Yes. Really? Okay, good. All right, okay. All right, let's find m. Now, m is, you can do ratio of intercepts because these are intercepts. M over 5.3 equal to 4.7 over 6.2. Ratio of intercepts. So it's a very convenient theorem to apply, right? Ratio of intercepts. Let's make the screen smaller. Okay, good. So how do I find m? You just have to multiply both sides by 5.3, 5.3. That gets cancelled. Then you work out what m is using your calculator. So always convenient to put the pronumeral on the top because you just have to do one step. If you put the pronumeral at the bottom, it makes the question a little bit harder. 4.7 times divided by 6.2 times by 5.3 equal to 4.02. Doesn't say how many decimal places. Just say it's 4.02. Correct to 2 decimal places. 2 dec places. There's another pronumeral we're going to find in a minute. Oh, 4.02. 4.2, yep, got it. Now, can anyone suggest how to find P? Now, P is not intercept. What should we do to find P? Right, it's on the parallel line, so it's not really classified as an intercept. So we can't do these sort of things. So what do? You have to not guess and, well, how can you guess and check with? Because there's no equation to check with. Ratio of the sides of similar triangles. So we have to prove the 2 triangles are similar before we find P. Okay, so what you have to do is, okay, so yeah, sides are in proportion, but we have to prove it's similar first, because we haven't proved. So that's the sides, so let's write it down. So 5.3 plus m, and then the other one is 10.9, 4.1, 6.2, and 5.3. Okay, so 10.9 is 6.2 plus 4.7. Okay, so what we do is, let's prove the two triangles are similar. So maybe we can write things down like A, B, C, that's A, C, A, D, E. A, D, E. So, and then what we're going to do is to prove that similar. So you say angle DAC is equal to angle DAE, common angle, as well as that, you also have, now they are parallel sides, isn't it? So you will say that the corresponding angles are equal on parallel lines. So you say these two angles are equal. Angle ACB is equal to angle AEB, corresponding angles on parallel lines. Corresponding angles on parallel lines. Right, like that. So, and then what we do is say they are equiangular, so therefore triangle ABC is similar to triangle ADE, equiangular. And then we can do the ratio matching sides in similar triangles. So similar triangles are a bit hard. So now let's find out what P is, which I will use a different color. Okay, let's work out P now. So now we're ready to work out P. So P match was 4.1. And which other sides do we match? Yeah, 10.9 over 6.2. 10.9 over 6.2. And like before, we just multiply both sides by 4.1 in order to find P using your calculator. P equal 7.2, 10.9 divided by 6.2 times 4.1. Yep, 7.2 is correct. Correct to one decimal place. And the reason is matching sides in similar triangle. In similar triangles. Alright, done. Okay, these are all the reasons. I need to say one more thing before we move on. Now, what's the one thing we could do? Now, let's find M differently. What's the other way to find out M? The other way to find out M is to use similar triangle, isn't it? So if I want to find out M, you have to do 5.3 or 5.3 plus M over M equals to, yeah, no, but I'm using ratio matching sides, equals to 10.9, actually not over M, 5.3 over plus M over 5.3 equals to, bingo, okay, equal to 10.9 over 6.2, right? But can you see this is harder than doing this at the beginning, ratio matching intercepts, ratio of intercepts, than do the ratio matching sides, because this is harder, isn't it? When M is not on one of the sides, it's over here. So what you need to do, what do we do? To solve it, let's times both sides by 5.3, see if we get the same answer. 5.3 times by 5.3, cancel. You get 5.3 plus M equal to 10.9 divide by 6.2 times by 5.3 equal to 9.31. M equal to 9.31 minus 5.3 give you 4.02 as we know earlier, right? 4.02. But this is much harder, isn't it? And involves more work. So just keep an eye out for this theorem, ratio of intercepts, very fast to work out missing sides. But when it comes to sides on parallel sides, I can no longer use that theorem. I have to use this theorem, the similar triangles. Okay? All right, that's method 2. Method 2. Okay, any other questions? We now have to go through Pythagoras because this exercise only got 5 questions on this, 11 to 15. So we'll move on to Pythagoras, then you can do the work. So it took a while to do this. Okay, let's move on. Next page. All right, Pythagoras theorem is well known since year 8. Okay, Pythagoras theorem. We know that Pythagoras theorem says that a squared plus b squared equal to c squared. That's very, very easy. We learned that we did a bit of that in trigonometry. All right, so now we're going to do the converse. If the sum of the squares of 2 triangles are equal to the square of the third side, then the angle included by the 2 sides is a right angle. So what that means is that if I have a triangle, which I don't know it's a right angle, if I test it by doing the square of these 2 sides, it's actually equal to the square of the third side, the longer side, then it's a right angle triangle. So that's what this theorem also says about triangles. So that gives us an easy way to check whether a triangle is a right angle. So if the 3 sides satisfy the Pythagoras theorem, we call them the Pythagorean triad. Some of the well-known ones are 3, 4, 5, 5, 12, 13, and other well-known ones. And of course, you can also double every side, gives you another triad, because they're similar triangle, isn't it? You just do the ratio matching sides, they're similar. Now, how do I test this? So let's say I test this one. 5 squared plus 12 squared equal to 25 plus 144 equal to 169. And if I do 13 squared, it's also 169, so it's a triad. So the square of 2 smaller numbers is equal to the square of the third side, then it's a right angle triangle or Pythagorean triad. Okay. All right, now let's use that to do example 30. Find the length of diagonal AC. So in this triangle, you have to find the diagonal AC. So you use the triangle ABC. So you do AC squared equal to 4 squared plus 3 squared, which is 25. To find AC is to, and then you go 25, which is 5. All right, any question? Easy. All right, that side is known. Now we have to prove that AC is perpendicular to DC. Now, how do I do that? How do I prove 2 sides are perpendicular? Prove the triangle is a right angle triangle. Now, how do I prove this is right angle? You just go like this. You go AC squared plus CD squared equal to 5 squared plus 12 squared, which is 169. And then you do AB squared equal to 13 squared, also 169. So you have to show this working. And once you show that the square of 2 sides is equal to the square of the third side, therefore you say triangle ACD is a right angle triangle. Okay, so that's what you have to do. And since it's a right angle triangle, we say therefore AC is perpendicular to CD. So you can use it to prove 2 lines are perpendicular. So you can use it to find missing sides, or you can also use this theorem to find the missing angle, which is a right angle. So if you know that it's going to be a right angle triangle, you can check whether it's a right angle by using Pythagoras theorem. All right, good. And then we'll go one more thing about The next one, 31. Find the missing sides. Okay, so I'll finish. Find the missing sides in a 3D shape. I think you've seen that before in year 10 or year 9. Alright, okay, let's do that. All done? Okay, find the length of the longest stick that fit inside the box. So the longest stick will be the stick that joined from this end to the other end. Okay, and to find this length, you first find this length first, which is the red line. So to find the red line, let's call that x. X squared equals to, it's a right angle triangle because it's a rectangle. X squared equals to 100 squared plus 25 squared. And then use your calculator. 100 squared plus 75 squared. And then you square root 125. So x equal to square root, which is equal to 125. Square root what number? 15 something. 15625. Okay, you found x. And once you find x, we'll note that this is a right angle triangle. Right? So let's call that y. This is 50. So to get y, you get square root of 125 squared plus 50 squared. And then you just work out on your calculator. 18125. They all have 125 at the end. Okay. Alright. So you just square root that. You will get correct to one decimal place, 134.6. Okay, square centimeters. Done. There's one more question on the next page on Pythagoras, then we're done. Have a try, see if you can work out. Just a slightly harder question. And the next lesson we'll do quadrilateral, and after next lesson we'll do polygons and area. And then after the next lesson, I think we'll finish by the end of next week. And then start another topic, and then your exam will be on very soon. Not just the term stuff we learn this term. Yeah, and after the exam. So a bit of trigonometry, a bit of most of trigonometry, except 6.1 to 6.5 that was in the last exam, and also we're going to be all of geometry will be in it, and maybe a bit of chapter 5 function will be in it as well. Maybe the first 3 exercise. Okay, next page, page 32. All right, we're going to find the length of DE. All right, so there are 2 triangles. There's 2 triangles. So let's look at which 2 triangles they are. There's this triangle, right? And there's another triangle. So we're going to use Pythagoras in both triangles to find out the missing sides. Now, they didn't label all the sides, so let's label some sides. So AB is 8, label, 15, label, AD equal to 25. So this length here is 25, as well as length of B is also 25. So to make it easy, maybe you can draw them separately. Actually, don't draw it separately. You may want to use it. Okay, and then this is 7. By subtraction, this is 7. 15 minus 8 is 7. So now you can find out the length of DC first. So maybe write down which triangle used. In triangle A, DC equal to the square root of 25 squared minus 7 minus 15 squared, and then use your calculator. Now, if you recognize this, 25 and 15, if you divide both by 5, you get 5 and 3, isn't it? So the third one must be 4. 4 times 5 is what? So you know it's going to be 20. Get it? Pythagorean try, 3, 4, 5. Or you can use your calculator. Okay, so just show you a trick. So it's not that I can calculate very fast, I just know that trick. Okay, 20. Okay, next one, I'm going to find EC. So you write triangle BCE, and then you write CE equal to the square root of 25 square minus 7 square. This one I don't know, so you just use your calculator. So you do 625, because I know the square of 25 is 625, minus 49, square root the answer. I think maybe, I don't know. Okay, answers 24. Okay, 24. And once you got these two lengths, one is 20, one is 24, therefore DE can be found, which is equal to, DE is, alright, so therefore DE equals to 24 minus 20, which is just 4 centimeters. Oh, they didn't say, just say 4. Done. Okay, good. So now we're going to start the exercise. The exercise are written on the board. You've got about 40 minutes to do. I'm sure you can finish one exercise before the other one, or finish both. Okay, good. So, done.